In this first example, we're going to do ammonia. Ammonia is NH3 and is the basis behind ammonium ion, which is NH4 with a +1. If we go through and do the calculations, we find out that nitrogen has 8 electrons as an octet because it's not one of the exceptions. There is only one nitrogen, so we have a total of 8 valence electrons if nitrogen were to have an octet. For the hydrogen, if it has an octet, remember it's an exception, so it's only going to have 2, and we have 3 hydrogen atoms in the ammonia molecule. That's going to give us a total of 6 valence electrons if hydrogen were to have an octet. We add these together, and that gives us a total of 14 electrons if we have an octet for all of our atoms. For the actual number of valence electrons, nitrogen has 5 because it's in group 5. So we have 5 valence electrons actually from the nitrogen. For the hydrogens, each one has only 1 valence electron. There are 3 hydrogens, so that gives us a total of 8 valence electrons or actual. Now, we find the difference between these two values, divide that by 2, and that gives us 3 lines that we're going to need to represent. When we go through and draw our ammonia then, we will have our nitrogen in the center. We will singly bond our hydrogens to that nitrogen to represent our 3 lines. And now we check for octets. Each of the hydrogens has 1 line attached to them, which means that each hydrogen has 2 electrons represented, and that gives them their octet. The nitrogen has 3 lines attached to it. That means it has a total of 6 electrons represented, and we need to have 8. To represent those the 7th and 8th electron, we simply put 2 dots around the nitrogen, and our Lewis structure is now complete. Our next example is going to be sulfur trioxide. In sulfur trioxide, we've got sulfur and 3 oxygens. Go through and do our math. We get a sulfur. It's going to have 8 valence electrons if it were an octet. There's only 1 of them, so that gives us a total of 8 valence electrons as an octet from sulfur. For oxygen, we have 8 as our octet again. There are 3 oxygens. That gives us a total of 24 electrons from the oxygens if they all had an octet. We add those together, we get 32 electrons if they were an octet. Sulfur actually has 6 valence electrons. Oxygen also has 6 valence electrons. And together, that would give us a total of 24 valence electrons actual. We find the difference between those two values, 32 minus 24. That's going to give us a total of 8. We divide that by 2, and that's going to give us 4 lines that we need to represent in our Lewis structure. Now, all of the atoms have 6 valence electrons, but sulfur is the single atom in this compound, so we will have sulfur in the center. We singly bond each of the oxygens to the sulfur, and we find that the number of lines that we need to draw is 4, but right now we only have 3. So we add a 4th line, making 2 lines between any one of these 3 oxygens. I have chosen this one. We now go through and check to see if we have an octet. The sulfur has 4 lines attached to it, each one representing 2 electrons, so the sulfur has the 8 electrons that it requires. We now go and look at each of the oxygens. This oxygen has 2 lines attached to it, so that represents a total of 4 electrons. We need to add 4 more electrons, so we add 4 dots as 2 pairs around that oxygen. That gives us our total of 8. These 2 oxygens are the same. Each one only has 1 line. That means that each one only has 2 electrons represented. So we need to add a total of 6 dots, or 3 pairs, around each of these oxygens. And when that is done, we have our complete Lewis structure. In the next two examples, we're going to do ions. We already saw ammonia, so let's look at ammonium. The ammonium ion is NH4, it's got a +1 charge. We go through the procedure, and for the octets, the procedure is the same as we've done already. We've got nitrogen. If it had an octet, it would have 8 electrons. There's only one nitrogen, and that's going to give us 8 electrons. For the hydrogens, each atom has 2 electrons if they're an octet. We have 4 of them. That gives us 8 electrons total. Together, we have 16 electrons if they were an octet. We now go through and do the actual number of valence electrons. Nitrogen actually only has 5 valence electrons. The hydrogen actually only has 1 valence electron. That would give us a total of 9 electrons actual. But we're not taking into consideration the fact that this has a +1 oxidation state. Because of that, we need to change this actual value. If something has a positive charge, that means that it has lost electrons. So we need to subtract 1 electron because this is a +1. That means overall this molecule has lost 1 electron. And that gives us 8 electrons actual after we've taken consideration the positive oxidation state. We now go through and do our differences. So we get 16 minus 8. That would give us 8. We divide that by 2. That gives us 4 lines. We now can draw our Lewis structure. The nitrogen is going to go in the center. We singly bond all of the hydrogens to that central atom. And now we go through and consider what our values are. The nitrogen has 4 lines attached to it total. That means it has an octet. Each hydrogen has 2 lines on them. Those all have an octet. The last thing we do when we're dealing with a charged ion is we put it in brackets and we put the positive charge up here. This represents that this molecule overall has lost 1 electron and has a +1 charge. We don't know what atom lost that electron because they all are in a cloud as a group, but this molecule overall has lost 1 electron. Our last example is going to be the carbonate ion, CO3 with a 2- charge. Let's go through the process. We get carbon. As an octet, we'll have 8 valence electrons. There's 1 atom of it, so we would get 8 electrons. For the oxygen, it would also have 8 electrons as an octet. There are 3 of them. That would give us 24 electrons. Total, we would have 32 electrons if they were an octet. The actual number of electrons, carbon has 4 and oxygen has 6 valence electrons. That's going to give us a total of 22 electrons actual. But we also need to take into consideration, again, the fact that this is a charged particle and has a 2- charge. The 2- means that it has gained 2 electrons. So for the actual number of electrons, we are going to actually add 2 electrons to give us a total of 24 electrons. When we take into consideration the electrons that are from the atoms themselves, along with the fact that we have gained 2 electrons somewhere. We continue with our math. We find a difference. 32 minus 24, that's going to equal 8. We divide that value by 2, and we're going to need to draw 4 lines. So we have carbon in the center. We singly bond all of the oxygens. We find that we have only 3 lines represented, but we need to represent a 4th. So our 4th line is going to go between one of these oxygens. We checked for an octet. The carbon has 4 lines. The carbon has its octet. This oxygen only has 2 lines, so it has 4 electrons. We need 4 more. We draw 4 dots as 2 pairs. This oxygen has 1 line as well as this one. So both of these oxygens need to have 6 dots added to them to represent the octet. So we write 3 pairs of dots around each of these oxygens. Last thing, brackets, 2 negative to represent that overall this molecule has gained 2 electrons. Which atom has gained those electrons? We don't know, but again, they all go into the same cloud around the molecule, and this is representing our carbonate ion.